By tiny we mean that something like the order of the atom, 1 angstrom, 10 power minus 10 meter. So if the size of the system is 10 power minus 10, so you need to use the quantum mechanics. You never can use the classical mechanics. That was the mistake which they did. For example, you know in the history of physics and chemistry, because physics and chemistry were the same science before, you know, before the quantum mechanics they were the same. After that they divided actually. So you know that the model which they made for the simplest atom, the hydrogen atom, was they consider a proton here and they consider an electron is the circulating around the proton. That was a very elementary model. And the problem was that they thought that they can use the Newton mechanics still for that. And you know that it didn't work for them because they had some phenomena they were not able to explain by the Newton mechanics. So Newton mechanics is not able to give you something here. Just you can give some things which Niels Bohr used the Newton mechanics. I mean, he used the same concept as we call it angular momentum. You know, when an object is rotating around a fixed point, so not only the velocity will be contributed that, but also the rotation makes some additional momentum to the system. We call it angular momentum. So Niels Bohr used the quantum mechanics plus one principle. He called it this. Call it quantization of angular momentum. And do you know what he found? He almost tried to explain the energy level of hydrogen atom using these two simple principles. And it works, it perfectly works, because it showed that his idea was really interesting. Just keep it quantum mechanics and the Newton mechanics and added one principle to the yours. The principle was that, I don't know, you remember that from the modern physics, that he considered that the angular momentum, which we call it L is R cross P, and this is R cross mv. R is the position, and this is the momentum. Yeah, he considered that this L, not all but he considered that the component of the L around the one axis, because this question, you know, this is actually electron is rotating around that in 3 dimensions. So he considered he added this principle that the Lz, the Z component of the L, if you consider that n multiplied to some constant, and give the permission to n to give any number, 2 plus 3 and this, and add this to the Newton mechanics, you almost find the same energy level for the hydrogen atom as people found in the experiment. Like the Balmer series, and you know this is story. You can read it in any historical book in modern physics. So you still can keep Newton mechanics and add the principle. But that's not enough. Because still you were not able to explain the whole description of this system, you know.
Because
for example,
only for hydrogen.
Yes. What was the main problem that Niels were not able to solve by that? You know?
Double sodium line. Sodium?
No, the radiations. He was not able to explain the radiations of that when the photon is emitted from the upper level to the lower level. So that will be a photon emitted. So, and it seems that when the photon is emitted, so it seems that the system becomes unstable. He was not able to explain that. Not he was a great person actually.
Doctor, when emitted or when absorbed?
It's the same, absorbed, this photon, no, emitted. When it's emitted from here to this level, and this photon now is free. So it can be captured by something else. But we are not talking about that, we're just about emitting. So that was not possible to explain it. So if you are going to tiny system size, you have a different physics, so this is will be quantum mechanics. So quantum mechanics is in this size. I want to tell you that what is the main question in quantum mechanics? Main question. Main question is, and we needed that in our course, is finding the state, finding the physical state and energy of the state. You know, I think it's one more than the classical. In classical mechanics, you need just to find the final path for me. I want to know that what is the final destination. If you start from this point, I want to know that with this velocity, can you reach this point or no, the second point or no. I'm not interested that to know